All right, so yesterday we got our hands dirty with the body of a computer, all that hardware. But today we're going to give that body a soul. We are diving into the world of software. You know, this quote just absolutely nails it. Think about it. Without software, all that amazing, powerful hardware we talked about, it's just a box, an expensive one at that. Software is what breathes life into it, telling it what to do, how to do it, and how to actually be useful to us. Let's really stick with this whole body and soul idea because it's the perfect way to think about it. The hardware, that's the physical stuff, right? The chips, the screen, the keyboard. But the software, well, that's the magic. It's the intelligence, the instructions, the very thing that turns a lump of metal and plastic into a tool that can literally change the world. Okay, and a quick heads up, especially for those of you studying for competitive teaching exams in India, the KVS, NVS, or EMRS. Pay close attention. We're going to zero in on 3 super important areas that pop up all the time: the different kinds of software, the job of the operating system, and the classic showdown, compilers versus interpreters. So, where do we even begin? Well, let's start with the fact that not all software is the same. It's kind of like a big family tree with different branches. And trust me, you're gonna want to know these branches. It's crucial for those tricky, find the odd one out questions on exams. Right at the base of our tree, the foundation, we have system software. Think of this as the ultimate manager, working tirelessly behind the scenes to make sure the whole show runs without a hitch. This is your operating system. The drivers that let your printer work, the translators, all the stuff you don't really see, but absolutely nothing would work without it. Okay, so if system software is the behind-the-scenes manager, then application software, well, these are the stars of the show. These are the programs you're actually clicking on to get stuff done. Writing an email, browsing the internet, playing a game. Some are general-purpose tools, while others, like, say, a specific accounting program, are built for just one special job. And finally, you've got the crew that keeps the whole place running smoothly. Utility software. I like to call these the housekeepers. They're the essential tools that keep your computer healthy and happy. We're talking antivirus programs, tools that clean up junk files, or software to compress big files. They're the real unsung heroes of a happy computer. Now, let's zoom in on the big boss of system software, the operating system, or OS. The best way to think about it, it's a translator. You speak human, right? Your computer speaks, well, machine. A language of ones and zeros. The OS is that essential bridge that lets you two have a conversation. And man, is the OS a master multitasker. It's like an air traffic controller for your computer. It's constantly juggling which program gets to use the brain, the CPU, how much memory each open app gets, where all your files are stored, and who gets permission to do what. It's a huge job. So, how do we actually give commands to this powerful OS? How do we tell it what we want it to do? Well, that brings us to the user interface, which is really just a fancy term for how you interact with a computer. And this is a really big topic for your exams, so listen up. Let's put these two head-to-head. On one side, you have the CUI, the character user interface. Think of those old-school hacker movies with a black screen and green text. You have to type in exact commands. It's powerful, for sure, but you gotta memorize everything. Then, on the other side, you have the GUI, the graphical user interface. This is what we all use today. Icons, windows, menus, a mouse. It's all visual and super intuitive. Just point and click. All right, let's switch gears and tackle another huge concept. We humans, we write code in languages that kind of look like English, like Python or C++. But computers, they have no idea what that means. They only speak one language, binary, ones and zeros. So how do we bridge that massive gap? Simple. We need a translator. The first type of translator is called a compiler. Picture this. You write a 10-page essay, and you give it to a proofreader. The proofreader reads the entire thing, marks up all the mistakes with a red pen, and then hands it back to you. A compiler does exactly that with your code. It checks the whole program at once, and if everything looks good, it packages it up into a single, super fast file that's ready to run. Now let's look at the complete opposite, the interpreter. This is more like a live translator at a press conference. It takes one sentence or one line of code, translates it, and says it out loud. Then it moves to the next. If it hits a word it doesn't understand, it just stops dead in its tracks. This can be great for debugging, but it means the program gets translated from scratch every single time you run it, which can make things a bit slower. Okay, everybody, this table right here, this is your golden ticket for the exam. I'm serious. If you only remember one thing from this whole explainer, make it this. Compiler,
Whole program, all errors at the end, faster runtime. Interpreter, line by line, stops at the first error, slower runtime. Got it? Awesome.
And for our last big topic, let's talk about something that affects you every single day. Who actually owns the software we use? This isn't just about paying for it. It's about who controls the code that's running on your phone, your laptop, everything. So there are basically two camps. First, you have proprietary or closed source software. Think of this like the secret recipe for Coca-Cola. You can buy a can of Coke, but you have no idea how they make it. The recipe is locked in a vault. With software, you're buying a license to use the final product, but the source code is a secret. Then you have open source. This is more like a community potluck dinner. Everybody shares their recipes, anyone can look at them, and you can even suggest changes to make a dish better. The code is out there for everyone to see and improve. And you use proprietary software constantly. Microsoft Windows, Mac OS, the entire MS Office suite, Adobe Photoshop. These are some of the biggest, most polished products out there. But the code that makes them tick? That's a very closely guarded secret. But here's the cool part. You probably use a ton of open source software and don't even know it. That Android operating system on most of the world's smartphones? Yep, that's open source. The Firefox web browser? Open source. That amazing VLC player that can handle any video file you throw at it? You guessed it, open source. So I'll leave you with a little something to think about. Go ahead, pick up your phone right now. Look at the apps you use every single day to chat with friends, to check your bank account, to find your way around town. Are they open or closed? And more importantly, who really gets to decide what you can do with the software that runs your life? Kind of makes you think, doesn't it?